All right, so now welcome to part two of our tutorial on hypothesis testing for means and proportions, but this part two will focus on hypothesis testing of proportion, population proportion. So let's do this question 983, and then you will do 984. All right, so the question reads as follows. The technical changes in golf clubs are affected by the way golfers of all abilities are able to play the game. The impact seems to be especially great for professionals. Suppose there is a controversy over whether professional and amateur players should have different rules for what constitutes legal golf clubs and equipment in general. One golf organization has decided or indicated that more than 50% of all golfers believe that the rules should be different for professionals and amateurs. To test this, a survey of 300 randomly selected golfers found that 200 said there should be different rules. So 300 were sampled or surveyed, and 200 of them. So that's actually two-thirds of them. You can see that looks pretty strong relative to the 50% that is claimed. We said more than 50%. And in the sample, we get 66%, almost 67%. So you want to pretty much believe that we were rejecting our hypothesis, but before we can do that, we need to go through the process, right? So test the organization's claim. What should be the null and alternate hypothesis based on the sample data? Alpha 5%. Use the p-value approach to test whether the null hypothesis should be rejected. So I'll do this one, and you will do the next one. So let's just make sure we understand. So 50%, more than 50% believe that there should be different rules. So here we go. Step one. Hypotheses. HO, HA. So if more than 50% believe there should be different rules, that's what we're going to try to prove. The opposite of that is that 50% or less believe the rules should be different. So we could say 50% or less believe there should be different rules. Right? Which means more than 50% believe there should be different rules. HOHA, so 50% or less, it means that the proportion will be less than or equal to 50%, greater than 0.5. Folks, don't make this mistake. Most people will actually sometimes write this for me. P bar greater than 0.5, P bar less than or equal to 0.5. Excuse me. Remember, P bar is your sample. You observe that. You're not hypothesizing about a sample. You're hypothesizing about a population parameter. So we got to use P, we got to use mu. Not X bar, not P bar. All right? So that's step one. Step two. Since we're doing the proportions, step two, our test statistic. Now you recall that we have a rule that allows us to determine if you can use a normal approximation to a binomial. This is a binomial problem. Either you agree or you disagree that the rules should be different. So it's binomial. And the rule was that n times p must be greater than or equal to 5, and n times 1 minus p must be greater than or equal to 5. So in this case, n is 300, and then we say 50%, so that means that that's 150, which is greater than 5. So we're good to go. And if we do n times 1 minus p is the same value. So we're good to go with the normal approximation to the binomial. So our test statistic is z is equal to P bar, remember sampling error, minus over the standard error, 1 minus P over N. Excuse me. right? So that's a test statistic. Decision rule 3. So the decision rule, is this a right tail test or left tail test? Well, when we look at the research hypothesis, the arrow is pointing to the right. It's a right tail test. We're looking for evidence that the proportion is greater than 50%, which means this is alpha 0.05. This is our Z critical. With 5% in the tail, 1.645 is our critical value. You should know that by now. Reject the null hypothesis if we're in this region. If we're in this region, we fail to reject the null hypothesis. All right? Cool. So that's our decision rule. And of course, the p-value approach simply says if the p-value is less than alpha, reject the null hypothesis. I'm not going to bother writing it here again, but it stays the same no matter what the problem is, which is one of the things I like about it. Now, let's look at step 4. So 4, analysis. We need a sample proportion. That's 200 over 300. This is 0.667. And so we have Z is equal to 0.667 minus 0.5. Just basically follow the formula. 0.5 times 0.5 over 300, which gives us a value of 5.79. This is actually quite large. All right, so our p-value, since this is a one-tailed test, would just be the probability of Z going beyond that point. Well, for all intents and purposes, we know that this is less than 0.001. Sorry, because in our Z table, 3.09 gives us 0.001. So 5.79 would be much less than 0.001. In case you're not convinced, you want to see it for yourself, let's look at the Z table. So if I'm looking for the area in the tail, rather than use this side, I'm going to use this one. And 3.09, the area to the right of 3.09 is the same as the area to the left of 3.09. So if we look over here in the table, this is negative 3.09. And this is the area to the left, or that's what's in the tail. So the area to the right of 5.79 is the same as the area to the left of negative 5.79. So negative 5.79 would actually lead to an area that's less than 0.001. Okay? That should not be hard to see. If this is negative 3.09, then this area is 0.001. So where does negative 5.79 fit? It's deeper into the tail. So this would be the area to the left of 5.79. So it is smaller than 0.001. Cool. So let's finish this off. Our p-value is less than 0.001. And so step 5, our decision and conclusion. The decision is always just based on whether or not we reject the null hypothesis or not. So since critical value approach 5.79 is greater than 1.645, reject the null hypothesis. What's our conclusion? Now our conclusion has to do with the hypothesis that we stated. So we say we have strong evidence more than 50% of the golfers believe the rules should be different. All right? So, can we commit an error? The answer is yes, but in this case, possibility of type 1 error. Okay? And that probability of type 1 error is less than 0.001 for this test. Okay? Good. So we are taking much less risk than the 5%, so it's okay to reject the null hypothesis. So now it's your turn to pause the video and then do the next question. That question is 984. Okay? So do 984 and you will come back and check to see if you've done it correctly. So now I'm going to work it out, but please try it before you actually go ahead and look at the answer. All right, so let's see the question first of all. It says an advertising agency on the West Coast formulated a media advertising campaign for an online retailer and claims that its ads receive high approval by at least 21% of adults with incomes over $50,000 per year. Suppose the online retailer wishes to test this claim. It surveys 883 customers or adults with incomes over $50,000 and find that 168 gives the ads high approval. State the hypothesis and test a claim again at 5%. It doesn't have to be 5% all the time, but it's just these questions all seem to have 5%. They like 5%. But if you know how to do 5%, you know how to do 1%, 2%, 2.5%, okay, 10% and so forth. So it's all fine. Quickly, just the data that we have here. We're going to need a p-bar. So what's our sample? It's going to be 168 over the 883 that we surveyed, in which case that sample proportion is going to be 0.19. 0.1902, I'll just leave it at 0.19. So that's kind of what we need from here. Okay, we know our alpha is 0.05. If there's 5% in the tail, if it's a one-tail test, then what is our critical value? In this case, it is a one-tail test because we're trying to prove that at least 21% of adults actually give the ad high approval. So that's going to be a one-tail test, at least 25, one direction. Not that it differs from 21%, but at least 21. So 21, 22, 23, 24, 25, that's a particular direction. So this is going to be a one-tail test, which means that our critical value will be based on 5% in the tail, 1.645. So that's, you could actually check that out yourself. Okay, so that's, excuse me. So our hypotheses, notice it's something brighter. Going back to my yellow, I love this color. So hypotheses, HO, I'm not seeing any changes here, so let's see what's happening. Sorry about that. So HO, HA. So proportion is, so we're told at least, is claiming that at least 21%. So we'll say, let's assume that is true, at least 21%. We're going to try to find evidence that it's not 21%. Right. Now, another reason why you want to actually make sure that you have HAP is less than 21%, because if we look at the data that I showed you here, you notice that our sample evidence is 0.19, which is actually less than 21%. So you must make your research hypothesis consistent with what the sample evidence is telling you. Sample evidence is actually suggesting that it's less than 21%, which means that in your hypothesis here, the research hypothesis, the sample data is going to try to support the alternate hypothesis that says the proportion is less than 21%. Okay? So that's the null and research hypothesis. That's step one. Step two, test statistic. Sampling distribution is proportion based on proportion, p bar minus p over the standard error, p times 1 minus p over n, square root of p times 1 minus p over n. 3, decision rule. It's a one-tailed test, but this time this is a left-tailed test. Look at this. It's pointing in the left direction. And so, this is alpha, 0.05. This is a standard normal, so our Z critical is negative 1.645. Why negative? Because we're in the left tail of the distribution. So this is our rejection region right here. Reject HO. Okay? So if our Z value is less than negative 1.645, reject the null hypothesis. Otherwise, we fail to reject it. Otherwise, fail to reject HO. Okay, we fail to reject it. Step 4, our analysis. So our sample proportion, I said already, was 0.19, population proportion 0.21, 0.21 times 0.79 over 883 actually gives us, I know it's not strong enough, let me just find my value here. Turns out to be negative 1.46. Negative 1.46. All right. So if I look up p-value, is the probability of Z being less than or equal to negative 1.46. So if I go to the table, let's see what we get. Less than negative 1.46. Negative 1.4 right here, and 6 will take us 0.0721. All right, 0.0721. So p-value is equal to 0.0721. As you can see, this is greater than 5% alpha. This is greater than alpha. So we are not going to reject the null hypothesis. So step 5, our decision, conclusion. Since we're doing p-value approach, 0.0721 is greater than 0.05, that's alpha, we fail to reject the null hypothesis, HO. What's our conclusion? We have insufficient evidence to refute the advertiser's claim. Okay, we could not reject it. We could not reject it. Even though we got a sample proportion of 0.19, it was not enough. The sampling error was only 1.46 standard deviations away from the mean. But we said to be considered an outlier in this case, you have to be 1.645 standard deviations away from the mean, and so therefore the evidence is not strong enough. All right. What kind of error? Possibility of type 2 error. Why? Because we did not reject the null hypothesis. We could only commit type 1 error when we reject the null hypothesis. Okay? So when you reject the null hypothesis, you could reject it when it is true, and which means you should not have rejected it, and that you commit type 1 error. But type 2 error is when you fail to reject the null hypothesis when it is false. So it could be that the 0.21 is false, but we did not have enough evidence to reject it. So as a result, we have to leave it as is. Doesn't mean that you've proven the claim is correct, you just are not able to prove that it is wrong. And that brings us to the end of our tutorial. That should be plenty to make sure that you understand how to solve those problems. In addition to that, we have the video lectures that gives us additional problems to solve. And then we have the workbooks that give you additional problems. So you have a lot to go with. So hopefully you take advantage of all those resources, but it requires discipline. It requires that you set aside some time to be able to spend the time with the material to understand it. Okay, so thank you for watching and good luck. Take care.